Everyone, Mr. Aarons again here. Today we're going to be looking through this study guide. We're going to 4.3 to 4, or 4.1 to 4.3. We have a quiz coming up, so I'm going to run through a few of those questions, send you off on your way. Again, if you have any questions on any of this stuff, feel free to hop into my office hours whenever. I'm always there for you. So we're going to do about, I think, 8 of these problems together, and then I'll have you do the rest on your own. See how you're feeling, and hopefully crush this quiz. So the first thing they ask us to do is to sketch a graph, represent the situation, label X and Y. So I'm going to start by doing that. I know this is the X. I know this is the Y. I like to think of that Y has a stem that moves up and down, just like this. So that's why you're on the up and down for Y. And they tell us the average temperature slowly decreases over the course of a football season. So what I'm going to do here is I'm going to put time. I'm going to put my days over football season. Let's even just, I don't know, for example, I'm just going to toss in September, October, November. It doesn't really matter if you have those in there as long as you have days or football season. Putting that time on the bottom always helps to make it a little easier to see it as a timeline. And on this side, we're going to have our temperatures. And I'll just go 0, 20, 40, 60, 80. And I'm thinking at the beginning of the football season, we're thinking like August, September. It's going to be pretty hot. And you could actually, if you really were doing specific, do little waves like this for night and day every single day because it's going to get colder at night than it is at day. And it is going to tend to get lower. You're going to maybe have a few random spikes in there, but generally it's going to tend downward. And as it gets into November, it's going to get a lot colder. We're going to be sitting at like that 40 degree, 30 degree mark as we get into late October or late November. So that's how you can see your average temperature steadily decreases. So I decreased it there over the course of a football season. So as time went on, my temperature decreased. So just a rough graph there, nothing too specific, just making sure you're following the order of the graph. You look at number 2, they say the amount of milk in your bowl decreases as you eat. So you'll be time as you eat down here, the amount of milk in your cereal over here. Looking at number 4 here. They tell us for each table to make a graph, determine whether the relationship is a linear function. If it is a linear function, represent the relationship with an equation. Perfect. All right, well, the first thing that we always have to do here in order to figure out if that is a linear function is see if it has a common difference. I know linear functions are y equals mx plus b. And remember, this is our y-intercept. So when x is 0, and this right here is our common difference. So the first thing that I want to do right here is I'm just going to graph these on here. I'm just going to go 0, 1, 2, 3, 4. And on here I see that I really only need to graph -1. And for 0, we're at -1. For 1, we're at -1. And I can see all the way across, we're going to be at -1. And that would be my graph right there. I remember that a horizontal line can be a function, so I'm already feeling confident about this. Let's check out our table here, find that common difference. Plus 0, plus 0, plus 0. There is a common difference. It's plus 0, which is kind of weird. But we're going to do 0x plus, and at 0, it's -1 plus -1. And this can be simplified to 0 times x. Anything times 0 is going to be 0. So it's really just going to be y equals -1. We can see it making a straight line. That means it's going to be linear. And we have a common difference. So yes, this is going to be a function, linear function. It is kind of strange. It's a bizarre one, but it fits everything for us. Everything that we plugged in here, if we plugged in 2 for x, it'd be 0 times 2, which is 0, plus -1, and we're going to get y equals -1 for all of those. Do the same thing for this one. This one you're going to notice probably is going to be a little bit more of a functional graph. And we got one more example of this. So I'm going to write my y equals mx plus b. I always like to jot that out. Helps me out. And I'm going to graph this one out first. I see we're going 0 through 1. I'll spread this one out a little bit more. Or 0 through 3, excuse me. And y, we're going positives here, so we're going to go 0, 2, 4, 6, 8, 10, 12. All right, at 0 we go 5. At 1 we go 7. And my 0 is a little off. It should actually be moved over a little bit there, but I'm not going to worry about that too much. 2, we're going to go to 9, and 3, we're going to go to 11. This is looking pretty straight to me, looking like a straight line. Let's check it out. Let's find those common differences. Plus 2, plus 2, plus 2. I can see that common difference. It's going to be 2x plus, when we're at 0, y is 5. That's that y-intercept. And that would be your equation. Y equals 2x plus 5. Yes, this is going to be linear. We could check it out by plugging one of these in. Let's plug in 3. That would give us 2 times 3 plus 5 equals y. And it should be 11 here. I'll get 6 plus 5 equals 11. And that checks out. Looking pretty. Moving on to number 8. Each set of ordered pairs is a function. Write a rule that represents the function. Well, I always like to start these out by writing them as a table. That's what I'm going to do. I see I got 1, 2, 0, 1, 2, 3, and 4. And over here we have 1, 5, 9, 13, 17. All right, let's see if we can find a common difference. Plus 4, plus 4. Oop, it's looking good for us here. And those are all plus 4. I see we have a common difference. That is always a good sign. I'm thinking my y equals mx plus b. Common difference is my m. That's going to be 4x. Y equals 4x plus, and that y-intercept, when x is 0, y is 1. Plug that one right in there. And we're done. Number 11, is the point negative 3, 7.2 on the line of the graph y equals negative 3.8, x minus 4.2. How do you know? Well, we already practiced this a few times. I put a little star next to this because you haven't seen this exactly. But basically all we have to do is we have to just plug this in for x, plug this in for y, and see if that's true. If it is true, then we know it's on the graph. So let's do that. It's just going to be 7.2 equals negative 3.8 times negative 3 minus 4.2. I'm going to jot this one on my calculator for the sake of time in this. And we're going to get negative 3.8 times negative 3 minus 4.2. Oops, I did 4.5 there. 1 point minus 4.2. And we get 7.2. It checks out. So check. This one works. I can say yes. If you plug the points into the equation, it checks out. Move on my back here. Number 12. They tell us consider the pattern. And we got a few steps here. So we're looking at this pattern here. The first thing they tell us is make a table, show the relationship between the number of cubes and the surface area. Okay, number of cubes. I see there's one with 1 cube, one is 2 cubes, one is 3. And surface area is the amount of sides shown. I see that there's 6 here. 1, 2, 3, 4, 5, 6. Second one, we got 1, 2, 3, 4, 5, 6, 7, 8. Third one, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I see that there's a relationship forming here. Let's write an equation. We're thinking y equals mx plus b. I see a common difference here of plus 2. So I know if I went back to 0, it would be plus 2 again. It would be 4. And this helps me out a lot. I got that common difference. Plug that in for m. And I got that intercept right here. When x is 0, y is 4. I can check that out. Let's plug it in. And we'll get, this one's kind of interesting because this doesn't work for our last ones because of that plus 4. Because if, I didn't think about that. Because if the number of cubes we have is 0, we don't have 4 sides. We have 0 sides. So this one doesn't work right here. So what we have to do is we have to get rid of this plus 4. Because it doesn't work for if there's 0 number of cubes, that's going to be an outlier in this case. But if we do have 4 cubes. This is going to continue to trend upwards. So all we really need is y equals 4x. Let's see here. Interesting. Let's see. 1, 2, 3, 4, 5, 6. I feel like I made a mistake here somewhere. Number of cubes, 1 is 6, 2 is 8, 3 is 10. We have that common difference. Okay. So 4 would be 12. But what we plugged in here isn't going to work.